Welcome to Problem Solving with Miss Jones. I've begun with a free body diagram for this, based off of the figure given. So we have mg down, which is the weight of the block, and then we have this 12 Newton force up and to the left, an angle of 30 degrees, and it's going to have an x component and a y component. At first, this is a frictionless wall. There would also be a normal force, which will come into play later. But if this block is to move, it's going to move up and down. So we want to deal with the forces in the y direction to see if it will accelerate. So we do sum of the forces in the y equals ma. If we get a positive number, it's going to accelerate upward. If we get a negative number, it's going to accelerate downward. And if we get 0, then it will either not move or move at a constant speed. So we do the forces up minus the forces down. So this Fy is going to be 12 newtons times the sine of 30, because that is the opposite side of that right triangle there. That force is upward, and then we have mg downward. Mass is 1 kilogram times 9.8, and that will equal ma. We usually write the mass here on the block, so I'll add that. So when we complete that calculation and solve for A, I got negative 3.8 meters per second squared. The negative means that it will accelerate downward. That means the mass, the force of the gravity, is stronger than this y component of the force. All right, now part B is adding in some friction. So I'm going to add something to the free body diagram, which is Fk, the force of kinetic friction, might be static friction. Remember, that's equal to mu times the normal force. So now we're going to need to find that normal force. So in order to do that, we're going to do sum of the forces in the x direction. And I'm going to set that equal to 0 instead of ma, because this block is not going to be moving in the horizontal direction. So we have the normal force to the right minus 12 newtons times the cosine of 30, which is the horizontal component of this force, and that equals 0. So when you do that math, you get the normal force equals 11.4 newtons. Now we can go back and do the sum of the forces in the y direction again to see what the new acceleration is when we add in friction. So sum of the forces in the y direction equals ma. So I'm going to write this out for you. It's mu times the normal force. We're going to add this y component of this, which was 12 sine 30, and then we're going to subtract mg here. That equals 0. So I kind of half substituted in here, but I just wanted to see where the mu came from. So mu, the coefficient of friction, is 0.12 times the normal force, 11.4, plus 12 sine 30 minus 1 times 9.8. Oops, that shouldn't equal 0. That should equal ma. And that equals 1 times the acceleration. So when you do that math, you get negative 2.43 meters per second squared. Again, that's down. So it's going down, but slightly less fast when you add in the friction, which makes sense. The friction will slow it down a little bit. So this is our answer for A, for B, I'm sorry. And here's the answer for A. And we had to solve for this in between in order to do this.